Hello and welcome to my channel. In this video, I am going to present concepts of acid. You must have seen that questions on acids and bases have always been an important topic from JEE and Neet point of view. Concept 1. Electron donating groups are those groups which can exhibit plus I and plus R effects. An electron withdrawing group, if present in a molecule, it decreases its acidity. Similarly, an electron withdrawing group, if present in a molecule, can exhibit minus I and minus R effects, thus increasing acidity. pKa is inversely proportional to acidic strength. It means that if pK value is less, then the acidity of the compound will be more. Let's compare the acidity between acetic acid and fluoroacetic acid. In case of fluoroacetic acid, the pK value is 2.7 and that of acetic acid is 4.8. Lesser the pKa, more will be the acidity. Hence, fluoroacetic acid is more acidic than acetic acid. What is the reason? An electron withdrawing group, in this case fluorine, pulls the electron density towards it due to minus I effect, resulting in decreased electron density over this oxygen atom. This oxygen atom in turn pulls the OH bond pair strongly towards it, releasing hydrogen as H+ with a greater ease. Hence, fluoroacetic acid is strong acid than acetic acid. So the acidity order becomes fluoroacetic acid is more acidic than chloroacetic acid, then bromoacetic acid, then iodoacetic acid and acetic acid. This order can be explained using the concept of electronegativity. As electronegativity decreases, the electron pulling tendency decreases and hence they become less acidic. Number of minus I exerting groups is directly proportional to acidity. It means if in a molecule number of minus I exerting groups more, it will show more acidity. It's clear from the table that in case of trichloroacetic acid, pK value is 0.64 and in case of monochloroacetic acid, pK value is 2.8. Obviously, trichloroacetic acid with a lower pKa value will be more acidic as compared to monochloroacetic acid. It is due to the presence of 3 minus I exerting groups in trichloroacetic acid. If we compare the acidity between formic acid and benzoic acid, we can come to a conclusion that formic acid with a lower pKa value is more acidic as compared to benzoic acid. Take formic acid molecule. Let's remove this hydrogen as proton. This hydrogen is acidic, so this hydrogen can be removed by treating with a base. Base will abstract this hydrogen as proton and the bonding electron pair between OH will be taken up by this oxygen. Thus oxygen will acquire negative charge, forming formate anion, and this formate anion is resonance stabilized. Similarly, benzoic acid removes its acidic proton and forms benzoate anion, which is also resonance stabilized. Now, in case of formate anion, this hydrogen does not do anything, meaning this hydrogen does not have electron withdrawing or electron donating power. But in the case of benzoate anion, this phenyl group does have -I and +R effects. And if you compare the strength of -I plus R, it's found that +R has more contribution than -I. Due to the +R effect of the phenyl group in benzoate, this phenyl group increases electron density over this oxygen. It enhances the electron density over oxygen, and hence it makes it more unstable. It destabilizes the molecule. So we can clearly explain the stability of the intermediate after deprotonation. In case of formic acid, we get stable resonating structures, but in case of benzoate anion, we get unstable because of this phenyl group. This phenyl group is exerts +R effect, and hence destabilizes the anion. So formic acid is more acidic than benzoic acid. Moving on to concept number 4, trifluoroacetic acid is 1,00,000 times stronger than acetic acid. The reason is due to the presence of 3 -I exerting groups in case of trifluoroacetic acid. Here 3 hydrogens, they have no electron donating or electron withdrawing effects. That's why acetic acid is less acidic as compared to trifluoroacetic acid. It has been observed that trifluoroacetic acid has a pK value of 0.2. Since pK value is very less, it means that it is very strong acid. These are the various pK values of many acids. If we compare hydrogen iodide and hydrogen bromide in the context of the acidity, we can see that hydrogen bromide has more pK value, -9. Hydrogen iodide has pK value of -10, which is less than -9. It suggests that hydrogen iodide with a lower pK value is more acidic than hydrogen bromide. Two chlorine atoms have more electron withdrawing power than that of single fluorine atom. It has been observed that dichloroacetic acid is stronger acid than monofluoroacetic acid. If we compare the electronegativity of dichloroacetic acid and fluoroacetic acid, as a combined effect, two chlorine atoms will have more electronegativity. I mean to say that it will have more -I effect as compared to single fluorine atom. So as a result, its pK value is less. That means dichloroacetic acid is strong acid as compared to monofluoroacetic acid. You can see that it is almost double. It's double the pK. That means it will be half of the acidic strength of dichloroacetic acid. Thank you. Please subscribe my channel for the latest updates of my videos. Click on like button below if you have liked this video. Please share this video on Facebook, Twitter, so that others can also be benefited.